And so, Andy and Olivia, we're turning it over to you.
Okay, so hi, we are conservation biology students at Heronwood Field Station, and my name is Olivia Shanker.
And I'm Andie Renault.
And so our talk today is about forest carbon. So I'm going to share my screen. Our presentation, like I said, is about forest carbon. Okay, so what does carbon have to do with the forest? So every single tree is able to sequester and take in carbon from the atmosphere, and then it is permanently stored. So the only time carbon is able to be released is if the tree is burned. And a small amount of carbon may be released when a tree is cut, but if it's not burned, it will forever hold that carbon. And so the project we're doing as Heronwood students is that both the AM and the PM class were able to survey the 90 acres of land we have here and get an estimated number of carbon that's being stored in our forests, so stored in our trees. And so the question we were trying to answer is how can we better conserve the Heronwood property to mitigate the effects of climate change? And so how and what do we measure? So when measuring carbon, we are using the size of the tree and the height to be able to calculate the amount of carbon being stored in it. And so these calculations tell us how much carbon is being stored in an individual tree. And then we can take that information and find out how much carbon is being stored in the entire forest that we have on our property. And so how can we measure the amount of carbon really being stored in a tree? So we measure carbon in a singular tree or throughout a forest with special tools and measurements. So for our project, we used a tape measure to find the DBH, which is diameter at breast height. And so that's, you wrap it around the tree, or you can use something called a Biltmore stick, and that's what's shown in the picture. And then we also use clinometers to measure the height, and other tools to help us to measure the plots, which also gave us more information that then we were able to use and use to be able to find out more information. And so throughout that, we were able to go around our property and measure any type of tree, but now we were able to gain those skills to go out and do it anywhere, which is a really cool experience. And we got to learn how to use all these different types of tools. And it was really helpful and educational because it's something that I think we're both really interested in.
So we used a AI to figure out our basal area, which was our plots. And from there, we took our basal area calculation was pi times diameter at breast height divided by 40,000. And then we converted that to the volume. So we did 0.5 times the height times the basal area. Then we converted it to biomass. So we took the volume, which we just found, and then specific gravity, which depends on the specific tree species, which we found in a table that was presented to us. And then we converted it to carbon. So we divided that by 2, or we times it by 0.5, because half of the tree's biomass is made out of carbon. So this was important because we also had to figure out how is our forest healthy. So we marked down all the invasive species, we marked down all the dead trees and all the saplings. And this is important because the healthier our forest is, the more it can sequester. So carbon sequestration is a natural way to take greenhouse gases out of the atmosphere and store them in our forest. And forests are vital to the survival of green spaces. So how can our forests help? Trees sequester carbon dioxide. Trees are made up / store about 50% of carbon by biomass. Forests are a carbon sink, so they take in more carbon dioxide than they emit. And then what carbon sources are places that emit more carbon than they take in. So carbon sources are really bad. but forests are carbon sinks. So what does greenhouse gases have to do with it? So greenhouse gases are gases in our atmosphere that are trapped, causing global warming and climate change. The Earth's albedo, which is like kind of the reflection percent, is 30%. So the sun rays comes in as a short radiation, and then they're bounced off and reflected off of the Earth as a long radiation. So this long radiation is getting caught in all these added greenhouse gases, causing the atmosphere to become more hot, causing global warming and climate change. So 79% of all the US greenhouse gas emissions are from human activities. Carbon dioxide is sequestered out of the atmosphere by our forests via photosynthesis. And then how can we better manage Heronwood Field Station to reduce the effects of climate change? So what we've done so far is we've planted more climate resilient trees such as white oak, red oak, bur oak, and flowering dogwood. We did classic research on which trees would do well in the future for climate change. The trees we planted will fit well in our oak hickory forest that we have at Heronwood. We also removed invasive species with KNC stewardship, such as mustard garlic, honeysuckle, and an array of more. While we remove invasive species, it's to help the overall health of our forest. So we did a traditional plotting technique, which we use these forestry prisms to count out how many trees were in the plot. So as you can see, if the tree overlaps, then it's in and we count that as one of the trees. But if it's out of the prism, then we do not count that in our plotting area. Then we will use a Baltimore stick to find the DBH, and then we will do the calculations as we talked about before. So we ground truth our data. So NCX provided an assessment of all the carbon stored above ground forest biomass across all of KNC properties. The NCX model calculates carbon estimates using remote sensing from satellite imagery and baseline forest metrics from the USDA Forest Services Forest Inventory and Analysis Program. So they took satellite images and they were able to calculate from those satellite images how much carbon was stored in our forests. So we took that data and then we compared it to our own. So we ground truth their data by using the traditional ways. And then we found out that we have roughly the same amount of carbon as what they found, which was 2,486 metric tons of above ground biomass.
Okay, so why is this important? So measuring carbon in forests can give us more information about how we can be better equipped to deal with climate change as a whole, and especially within our forests. So we can figure out how to manage our forests in a better way to help mitigate climate change. We can identify where invasive species are in our forests and we can figure out how we can help our forests to thrive. We can find where saplings are growing in our area and see how much carbon can and will be sequestered in the future. And then it's truly interesting to think and talk about how much carbon is being stored on the land you live on, you work on, or anything like that. It's always great information to have.
So that is all for our presentation, but we do want to show our tools that we use. So this is our Baltimore stick. I don't know how to present this in a manually way, but we showed on one of the previous slides, one of our students using them on a tree. And this is yet again to measure diameter at breast height. We also could use a measuring tape.
Yeah, we had special measuring tapes that had like radius information on it. So then another device that we used was our clinometer. And so this was shown in one of the slides. It's what you look through, and it has a number at the top and a number at the bottom. And then you do this equation to figure out the height of the tree. It's not super complicated, but you have to be able to keep both of your eyes open. And that's like the hardest part about it. But it's like, it's a little thing.
This is the prism that we used. It just looks like a clear thing, but it distorts things as you look through it. I don't know, yeah, you can like see, and then we use this to yet again figure out how many trees are in our plot.
Yeah, and then so the other thing that we used was, your classic measuring tape. This is kind of how we figured out where our basal area would be and like what our plot sizes would be. And there was a couple different options for us when we chose that, but I think as both classes we chose like 12 feet big. And so that was usually around 8 or 9 trees within each plot, which gave us a pretty good amount of information.
We also used it with the clinometer. Yeah, to help us find the tree height because we needed to know the distance we were looking up for it to put in the calculation to find our tree height.
Yeah, it was usually about like 30 to 50 feet away from the tree to be able to get an accurate reading. Yeah. So, any questions?
Oh, Rick, go ahead with your question.
Yeah, so it sounds like if we use wood for buildings, then that doesn't really harm the environment does not release carbon into the air and does not hurt the environment. Is that correct?
So something that a lot of people almost have like a miscommunication on is that building or furniture made out of wood is really bad for the environment. But realistically, like we're sitting in a building that is made out of all wood that's still storing the carbon it sequestered when it was growing. And so there's not necessarily anything wrong with wood buildings or wood furniture unless like the wood is very tempered and treated to look a certain way. But if the trees weren't burnt, they're technically still holding all the carbon that they sequestered. And so it's like kind of like a hot take, but wood homes or wood furniture is technically not bad for the environment at all.
But if you cut down the tree, then it can no longer sequester more, or if it doesn't grow, then it can sequester more carbon.
Yeah. So like the rings on a tree aren't like, it's the years, but it's the years because it shows how much carbon it's sequestering as it grows. And so once a tree is cut down, it can no longer sequester carbon, but it'll always store the carbon. So like when you cut down a tree, like there realistically a little bit of carbon is probably released each time, but it's still going to hold all the carbon that it like sequestered throughout its time.
Thank you.
Tim, you had your hand up next.
Yeah, and this relates to what you just said. When a tree dies and the wood decays, does that not then release the carbon?
So it does release the carbon, but a large part of it goes into the ground as it decomposes, and that gets put into the carbon biomass in our ground, which only adds more soil organic matter. But with added decomposition, there is a higher soil respiration. So the soil is breathing out more CO2.
Yeah.
But it is, when the tree dies, it does get decomposed and put back into our soil.
Yeah, it's like anything natural within trees and carbon sequestration and like carbon emission within like our forests, like it's meant to be that way. And so it's like realistically, if we weren't, like emitting CO2 from machinery and industrialization, like this would be a completely natural process and it wouldn't harm our environment at all.
Yeah, it would be a complete carbon cycle.
Mm-hmm.
Tom, you had your hand up.
Yeah, following up on Tim's question, it's the same idea I always wondered too, is that when it decomposes, it's somehow doing an oxygen combination. It's a slow burn, isn't it? So is there absolutely no CO2 that's released or carbon that's released as it decomposes? And then secondly, for Rick's comment, as long as you plant a new tree behind it, now you can maybe break even or stay at least close to even. But right, if you harvest the trees and then don't replace them, now you've lost the ability to sequester new. Huh? But yeah, if you can give me a little more detail on the decomposition, that was interesting, and it's always been a concern of mine because I have a lot of wood laying on my property that's fallen and things like that. I wonder what to do with it.
So decomposition as a whole is a completely natural process. and especially with fallen trees within forests, like I know we had that massive ice storm this year and a lot of people's trees fell. Like realistically, the best thing to do, I think, in my opinion, is leave it. Because if it's there and if it's on the land and if it fell naturally without someone cutting it down, then it will decompose in not like in the correct way. Like it's gonna go back into the soil and it's going to like complete the carbon cycle. And so it's like, and you said like, oh, if you if you cut down a tree and plant a new one right behind it, like that's a fix for it. But afforestation, like if deforestation is happening on like a large property, afforestation won't necessarily like fix anything that's happening within that, because it's still like the storage of the carbon and then the sequestering, like young trees sequester more carbon than old trees. And so it's not like an even battle between the two, in my opinion.
Yeah, and to play on that, it occurs to me that that's how we got the oil in the ground in the first place, was decaying plant matter and things like that compressed over millions and billions of years. So that's where the carbon comes from originally, doesn't it?
Okay, so Deb, you're next.
In En-ROADS, we were taught that it really takes about 30 years for a tree to start really sequestering any relevant amount of carbon. Is that accurate with your findings?
In my opinion, especially with my knowledge on En-ROADS, I don't necessarily think that's true, because I agree that it would take some time for a tree to seriously like start sequestering a good amount of carbon each year, but I wouldn't say it's 30 years. My guesstimate is probably around somewhere between 7 and like 9 years, because like as a tree grows, like I think we all know that it takes like quite a bit of time for there to be like a full grown tree that's storing a lot of carbon and sequestering. But I would say it's not any more than 10 years for a tree to fully be like sequestering carbon every season.
I also think it depends on what type of tree, because different trees have different growth rates, and some like you'll see will sprout out super fast, and some others will like, it depends on what environment they're in. So it really also depends on what type of tree and the environment it's in. If the forest is healthy, yet again, how much it can and is able to sequester.
Yeah.
So when they say that a smaller tree stores more carbon, what it is, it's by size, and because it's smaller, it does not store more carbon than a big tree would. It's just, it's growing, sort of like a baby grows faster for a certain length of time, and then their growth slows down until there's a growth spurt. So is that what the carbon is like with new trees, that it's being absorbed quickly, but it's not near as much as an adult tree would be absorbing?
So for saplings or like younger trees, they are taking in more carbon, but older trees store more carbon. So older trees, they sequester at a lower rate because they aren't growing as much. But younger trees do sequester more because they are still in that growing stage. So their younger trees are taking in more carbon at a higher rate, and older trees, they are taking in less carbon, but they're holding more because they've grown to the point where they're storing more carbon. That's also why deforestation isn't always the best thing, because when we're cutting down these old trees, yes, they may not sequester as much carbon, but they still are like a piggy bank storing all this carbon for us. But yeah, younger trees do sequester and take in larger amounts of carbon as they are growing, if that answers your question.
Okay. Could you talk a little bit more about soil respiration?
Yes, so I did a project on soil respiration, and so we did with our project is we did a plot where there was no added COM or soil organic matter, and we did another plot with added COM. and the added COM is adding carbon into the soil. So we found that with added carbon into the soil, the microbes are eating up all that added carbon. And what they're doing is they're breathing it out, like how we respire, the soil is more respiring. So as we're adding more carbon into the soil, eventually in its lifetime, it will emit more CO2. But yet again, once the soil emits that CO2, it will be sequestered by plants. And then once the plants die, it will decompose. And then as it's decomposing, the microbes will eat it. And it's a complete cycle. And that is the natural cycle. But what's important is afforestation, why we need to plant more trees, is because human activities are emitting more than the natural amount of carbon in our atmosphere. And that's why it's important to plant more trees, to sequester more, to really equate for the inequality of our human activity impacting.
Yeah, and then with that, it's like the idea of carbon sinks in like, what's the other word? Carbon sinks and
Carbon sources.
Carbon sources. Yeah. So it's like a carbon source is going to be something like a large industrialization like area, so like factories and anything that's burning CO2. And then a carbon sink is stuff like our forests, which are naturally sequestering CO2, and our oceans, which are also naturally sequestering CO2.
Sorry, Tom, I didn't mean to cut you off. I didn't see your hand raised.
I didn't raise my hand. Yeah, following up on the last thing you said, the main source around here probably for carbon is our cars. So everybody's driving a carbon source right there. And the other thing that occurs to me is looking out at the yard here, you see some big leaved trees. If leaves are what generate oxygen and put the CO2, let's see, they absorb the CO2 and generate oxygen. The more leaves you have, the better. And that makes sense to me that why a giant tree is doing a big job of absorbing CO2. And so the bigger the tree, the better in that respect. I'm not sure why a small tree would be better than a big tree.
So a small tree, we're not necessarily talking about like full growth size of a tree, but a younger tree will sequester more carbon in a year than like a bigger full grown tree will, just because that bigger tree is already storing a lot of carbon and isn't able to sequester as much. And this little tree is like ready to grow and see the world. And so it's going to sequester like a lot more carbon than a fully like a tree that's already storing almost like 45% of its biomass or something like that.
Could that be per weight though, in terms of percentage storage per weight? So a small tree maybe does more because than a large tree on a percentage basis. But I mean, if you put a little tree next to a big tree, I would argue that seems like anyway that the big tree is going to pull in more CO2 just to feed all those leaves and keep it alive, isn't it?
I mean, it could be the same amount just based off of like, oh, this one tree is really small and still growing and it's like only a couple of years old compared to like a bigger tree, because realistically they could be sequestering the same amount of carbon, but as a big tree it could be like, oh, sequestering more, and like this is a lot of carbon for like this small little like sapling. And so it could be around the same number, but it's not necessarily like, it's more likely that a smaller tree, a tree that's still growing that doesn't have that much stored carbon, is going to sequester more in like a yearly basis than a tree that's already storing a lot of carbon.
To add on to that, when trees are growing, so when they're growing, they use photosynthesis, and that chemical equation, I don't know if you guys are like into chemistry, but it's 6 CO2. So 6 molecules of CO2 plus 6 H2O, which is water. So what it does is it takes in the CO2 and it converts it into like biomass. And so that process of it taking in more carbon is what makes it grow bigger. So when like trees are needing to grow, they take in more carbon, and that's the rings in a tree, making it grow bigger and bigger. So when you have a bigger tree that's already has a high growth and storing a lot of carbon, is already that big, they don't need to sequester as much, take in as much, and convert the CO2 into biomass because it already has all that stored carbon.
Jennifer, you had a question?
Yeah, I'm just wondering about the Heronwood forest, and then other forests that are like that. So if you guys weren't planting trees, it's naturally regenerating at a whatever the normal pace of nature is, I would assume that trees are planting themselves and growing. So you're just trying to speed up that process with your additional tree plantings. And is that going to expand the acreage of the forest, or will it just become a more dense forest that can sequester more carbon?
Yes, so what we're doing at Heronwood is we're planting more climate resilient trees. With the climate change, some trees won't be able to withstand the added temperature increase. And so while we're planting more trees, we're making it so our forest is more climate resilient. Our acreage won't increase. We have 93 acres. Our acreage won't increase, but it will become more dense. And then why we're doing this is because there is a lot of deforestation. And so we're trying to plant as much as we can. So we're trying to plant as much as we can here to sequester more wherever we can, because we know other places they like to deforest and they don't replant whatever they have lost. And so while we're here planting them, we're just trying to increase our sequestration intake.
So can I follow that up with a little question about on a much smaller scale then, as a homeowner, I have some dying trees and I need to do something about them because they're probably a safety hazard. One already came down in the most recent ice storms. So my options for not releasing all that carbon would be either to let them just lay in the yard, which probably isn't practical. Maybe the tree service would turn them into compost. Are there any other? And then also I would want to replant with probably these more climate resilient types of trees so that I'm replacing them. But are there any other options for homeowners to, what can they do with their dead wood?
Mm-hmm. So I think there's a lot of places that will take your wood and use it in a way where it'll still, so like mulch is a really good example. Mulch is still storing carbon technically. And I think a lot of companies will take your dead trees and turn it into mulch for you. There's also like a bunch of other different ways.
There's also like people, I know like personally, like my grandparents, every time they see people like selling like their wood from their fallen down trees, they'll like buy the wood and then use that in their wood stove. So that's also always an option.
Yeah.
But it is very important if you could research what type of forest you have in your yard and see what type of trees would best fit in your forest, and then what trees would fit best in the forest going towards our changing climate as well.
Yeah. Okay. And then I wanted to talk about, so I got a tree cookie, which is a part of a tree. I don't know if we can see, but this goes back to the point that younger trees are going to sequester more carbon. So I'm going to try and show you in a way where you can definitely see it. So do you see how small all the ring sizes are as this tree got bigger? I don't know if you can see that. And then if you look in the middle, how much larger these ring sizes are, like how much larger the rings are away from each other. And so what that shows us is that indeed that this younger tree sequestered a lot more when it was young than when it was older, because we can see the years and how much carbon was sequestered.
Was it?
So yeah.
Okay, Rick, you have your hand up.
Yeah, I heard somewhere, and this, I might have not heard it correctly, but that grasslands can maybe sequester more carbon down into the soil than trees. Does that even make sense, or is there something about grasslands sequestering carbon?
So for grasslands, there are certain types of grasses like switchgrass that have these root systems that go like 20 feet under the ground. So imagine like a tree, but under the ground. So what they have is it's like a complex system of roots that store carbon. But I'm not sure which type of grasses may sequester more carbon dioxide than other trees. But I do know that there is a complex system of different types of grasses that will store all sorts of carbon underneath in the soil.
I think you heard that from Woody Harrelson in the movie Grasslands, the documentary talking about. That's one of the places that has been, that was a pretty popular documentary for a while there. Any other questions for our guests here? Well, great. I think this was a very interesting. I never knew that there was such a thing as soil respiration before. I mean, that was a complete new term for me. That's why I needed you to clarify it. I had, so the different species, and you got that off of a table. Now, I know that when they were planting at the nature center itself, they were looking for species, but with sort of a southern accent, so that they would be moving into a climate that's going to be adjusting. So is that Heronwood also is using that kind of logic about the growth of what you're planting? A, and B, where do you get your trees to plant? We have a gentleman here who's also very interested in planting trees in Africa. Do you know, what kind of suggestions would you be giving for him to be doing a tree forest there? If you know anything about that.
Okay, so to answer your first question, I think we got our trees from Native Connections, which also like
Okay.
gives, not gives, also like has native plant species that you can grow and other stuff like that. I'm not 100% sure on that. I can give you a resource.
We've bought like some seeds from them before for our like flowering unit.
Yeah.
So that's also where we get those.
Yeah.
Okay.
And then so what was the other question?
About a tree forest in Africa.
Oh.
And how to go about doing that kind of, it's sort of almost starting from scratch, I guess, you know.
Yeah, so I don't necessarily know anything about what kind of trees would thrive in that area, but I'm sure there's someone out there who has that information and knows all about this, probably even more than we do. But also at the Heronwood property, our whole goal with this project was to figure out a way to mitigate climate change on the land and like further be prepared for it within our forest. And so we did use trees from the south to like kind of prepare the land and prepare what like we have here for these hotter and warmer temperatures. So like these trees will be able to do well on the land even in the face of climate change.
To add on to that, it was the same tree species just with the different genetics from the south. So we're still keeping our native type of trees just with a little bit changed genetics to be more climate resilient.
Yeah.
Mm-hmm.
Okay, thank you.
Jessica Simons, our Vice President of Conservation Stewardship, did a presentation for Fridays for the Future on the KNC wide forest carbon assessment work that's being done. So if you're curious more about that, you can go back and watch Jessica Simons' presentation too.
Joshua, you might have to unmute yourself because I can't hear you. Okay.
I'm on now?
Yeah, you're fine now.
Yes, yeah. I'm very happy to hear all what we learned today. So my question was how we can find trees here in Kalamazoo to plant it.
We mentioned this place called Native Connections, but I'm sure there's other places in the Kalamazoo area that will sell trees too, that will be like climate resilient and be better for the area that you live in or where you're trying to plant the trees.
But that is another question. Invasive species, how do we, as lay people, know what is a relatively innocuous invasive species and what is one like the mustard garlic that you're supposed to be pulling and getting rid of and is killing off other things? How are we supposed to know or take that into consideration when planting things, like if Jennifer starts to try to plant trees?
So I don't think either of us have like quite that large of an information on invasive species, but like I know for a fact that like honeysuckle and garlic mustard are both like extremely invasive on our land, especially like on the Heronwood property. And so I think a lot of like research on your own part, especially if you're looking to do something with your property or like the land you work on or something like that, I think a lot of it can come from just like simple research about like, oh, I have this and I looked in an invasive species book, and is this like really harming my land? Like, does this need to be removed? Like ultimately.
And Jenny, you wanted to add to that?
Yeah, I have two things. The Nature Center ordered its big order of trees from a place called Woody's Warehouse in Indianapolis. And again, we got them from the South with the idea that they will, as climate changes, they'll do better up here. There are also places locally. It depends on how many trees you're looking for. If you're just looking for a couple trees, you could find a place locally. And then invasives versus non-invasives. Invasives is a native and non-native species is different than invasive or not invasive. So you can actually have native plants that are invasive and non-native plants that are invasive. And the idea of an invasive plant is that it's really opportunistic, and so it's really good at surviving and especially in disturbed areas. And so they are often the first plant to move into an area, and their populations grow really fast. So they're really good at competing against other things that are there. And so I'm sure there are, I don't have a resource off the top of my head for where you can find a comprehensive list, but I'd say a good idea is to just look it up and see if what you're about to plant is invasive or non-invasive. And then there are European species. It depends on how deeply dedicated to just natives you want to be, but there are not a native species that are not going to do a whole lot of harm. And then there are non-native species that are going to do a lot of harm. And then there are native species that are going to be really good at competing and take over and compete against other native species that are not as good at competing or take longer to propagate, that kind of thing.
Okay. Thank you, everybody, for attending, and thank you, Andie and Olivia. You were very knowledgeable,
Thank you guys.
Yeah, thank you for inviting us. This is a really awesome thing that we got to be able to do and be a part of. And we're thankful.